Okay, this is problem number 4 from your quiz, chapter 3 quiz. The first question says, which of the following statements is or are true? The first statement, and besides, I also have, there's a picture here. I'm just going to keep that hidden though for the time being because it doesn't come into play until question 3, so we'll keep that thing hidden. Okay, so first question, if triangle ABC is congruent to triangle BAC, then ABC is isosceles. And this is actually going to be true. And the reason it's true is because of the way that it's named. ABC is congruent to BAC. If I look at those two and just kind of treat them as if they're separate triangles, it tells me that AB is congruent to BA, which doesn't help me because that's like the reflexive property. But it also tells me that AC is congruent to BC. So in triangle ABC, I just deduced the fact that AC was congruent to BC based off of the way that the triangles were named to be congruent. So if AC is congruent to BC, that has to be isosceles. In fact, if I keep going, BC is congruent to AC. Oh, it's the same too. So it's just going to remain isosceles. So yes, that triangle actually is isosceles. That's a true statement. As goofy as that problem is, if you look at the way it's named and you take that fact, that's what you'll end up with. Okay, so that was part 1. We decided part 1 was true. Part 2, the perimeter of an isosceles triangle with base 10 is 20. That one doesn't even make sense. If I have an isosceles triangle with base 10, these other two sides have to add up to be bigger than 10, right? So if you talk about adding two sides, x plus x, it's got to be greater than 10. But if x and x are the same, then x needs to be greater than 5. But if the perimeter is 20, then x and x have to be 5. So this problem makes absolutely no sense. There's no limitation. If the base is 10, the perimeter could be 1,000,000. Okay, so the perimeter being 20, it's just kind of one of those problems that maybe tries to confuse you. But if you think about it for a second, you realize not only does it not have to be 20, it's actually impossible for it to be 20. Okay, so number 2 is actually false. So 1 is true, 2 is false. Now let's come back to this picture here. It says in PQRS, if PQ is congruent to QR, and RS is congruent to PS, then angle 1, 2, 3, and 4 are all congruent. Okay, well let's think about that for a second. If PQ is congruent to QR and RS is congruent to PS, well actually, let's break that down. All of these are congruent. So then angle 1, 2, 3, and 4 are all congruent. Well, I know from the fact that this triangle is isosceles, that angle 3 and angle 2 are congruent, and I know from the fact that this triangle PQR is isosceles, the angle 4 and angle 1 are congruent. So let's think about this fact. Would all those angles be congruent to each other based off of this fact? Well, let's think about congruent triangles. These two triangles, in this particular case, triangle RSP is congruent to triangle PQR because of side, side, side. All right, because of that, I know that the corresponding parts are congruent. So I know that angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. Well, I also know from the fact that they're isosceles that angle 2 is congruent to angle 3, and angle 1 is congruent to angle 4. So what you end up seeing here is you got a whole chain, 1 congruent to 4, 4 congruent to 2, 2 congruent to 3, 3 congruent to 1. So in fact, this is all true because, first of all, these angles are congruent to each other, 1 and 4 are congruent to each other, 3 and 2 are congruent to each other. And then you know that 2 and 4 are congruent by CP/CTC. And then these are congruent because if sides then angles. So basically what it creates are just a whole bunch of congruent angles. Yes, all 4 of those angles would be congruent. So the answer to this one would be B, 1, and 3. All right, I hope this helps you, and have a nice day.